Okay, guys. So what is this Rosenman reaction? This is what in this it is a formation of what? Aldehyde, right? In which carbonyl chloride reacts with PDBSO4, H2PDBSO4, and it converts into aldehyde. Okay, we have already done this, the name reaction in which the aldehyde formation takes place, formation of aldehyde. Okay, so reaction, if I write down here only just one single line, carbonyl chloride RCOCl when heated in presence of PD with BaSO4, poisoned with BaSO4, it forms aldehyde, which is RCH. Okay, this is the reaction. We have equal number of carbon atom we'll have here and here also. Cannizzaro reaction. In this reaction, we know that we take two molecules of aldehyde, like suppose I'm taking HCHO, and we use 50% of NaOH. NaOH, concentrated base we'll take here. One of the molecule will get reduced, forms alcohol, and another molecule gets oxidized and forms the sodium salt of it. So this is the Cannizzaro reaction we have. One will get reduced, other one will get oxidized. Okay, out of this, which one gives the isoform test? Many times they have asked this question. If you remember, methyl ketone, if it is present in any compound, CH3CO, methyl ketone gives positive iodoform test. Right? Answer is this one. Okay. Next question you see, this is the 29th one. Yeah. These reactions, you have to write down the product. See, if the reactant molecules are different, see formaldehyde, if one of the product you have Purvik, it always undergoes oxidation. See, what happens, I have done this in detail in class. You can refer your notes, you will understand. Okay, we cannot discuss all those things here again, but I'll give you just one thing. If you go through the mechanism, you will understand which one of the molecule will oxidize and which one of the molecule will get reduced. Right? There is a transfer of hydrogen, and then the reactions, the mechanism is given over there. One thing just you have to keep in mind here, if you have one aldehyde you have, and other one is formaldehyde, so formaldehyde always undergoes oxidation and the other molecule will go under reduction, right? Aldehyde with reduction gives alcohol, on oxidation gives acid. We'll get here salt of that acid. Okay, so which one will go under reduction or oxidation? That depends what molecule you have. But one thing you can assure, or you can keep in mind always, that formaldehyde, if one of the molecule is there, then this will always undergo oxidation and the other one will go under reduction. This you should know. Detailed mechanism, I have done this in the class. You go through with your notes, you will understand. Okay. Yeah. What is the product in the first reaction? Vicis is getting cyanohydrin. Hydrazone, second one. The first reaction is very common. We have done this many times. CH3CHO, C double bond OH, when reacts with HCl, H plus and Cn minus. So this OH will get and Cn will come over here. So the product here it will be CH3 C H CN OH. This is the cyanohydrin product we have. With NH2OH, what happens with NH2OH? We'll have oxime. It forms oxime, right? So the product will be what? CH3 CH double bond O when reacts with H2 NOH. If you remember, this O and H2 forms H2O, and this carbon attached with the nitrogen with double bond. The product here it will be CH3CH double bond NOH, oxime formation. Okay, CH3CHO in presence of dilute NaOH. CH3CHO. What is this reaction? Tell me. Can you tell me the name of this reaction? Aldol condensation. So what is the product we get here? Do we have condensation takes place? Do we have condensation here in this reaction? Product here it will be what? CH3 CHOH CH2, sorry, CH2 CHO. Right? After this, if you heat this, which is not the question, the answer is this only for this question. But if I go forward one more step, if here also if you heat this, then the product will be what? One of this hydrogen and this H comes out as H2O and it forms CH3CH double bond CHCHO. Right? But since there is no heating, so condensation won't take place here. Condensation won't take place, but only aldol forms here. So product will be aldol. Right? B. Test to distinguish the following pair of compounds. Benzoic acid and phenol. See, phenol, I'll just write down here. With neutral FeCl3, it forms violet color. With neutral FeCl3, it forms violet color, but benzoic acid does not react with. With FeCl3, there is no reaction with benzoic acid. So with neutral FeCl3, we can distinguish benzoic acid and phenol. What about propanol and propanone? This is easy, right? Iodoform test we can use here in the second reaction. Right? The keto group gives you iodoform, positive iodoform test, and the aldehyde won't give iodoform test, right? So that's the reaction we have. For the second one, we have iodoform test, and for first one, we use neutral FeCl3. Yeah, we can use FeCl3, NaHCO3 test. We can also use, right? Any one of these you can use. Okay, so this is the answer. Question number 28. I've done this. E1. Yeah. With reference to structural variability and chemical reactivity. Let me check this question. I think something is missing here. Question number 28. With reference to structural variability and chemical reactivity, write the difference between lanthanoids and actinoids. Okay, so actually here, let me correct this name of the member. Okay, so this is not the second one. Okay, this whole thing is the first question till here. So with reference to structural variability and chemical reactivity, write the difference between lanthanoids and actinoids. Actually, it is. Second question is name the member of lanthanoid series which is well known to exhibit +4 oxidation state. Correct. Complete the following reactions. Okay. Fine. Question number 1. Yeah, it's actinoids. Correct. So what is the difference basically we have here? We can also talk about here about the oxidation state of lanthanides and octanides. And one more thing, actinides, all the elements are radioactive in nature. Okay, just 2 points you tell me. Done. Greater range of oxidation states. Yeah, fine. Actinoids, these 2 3 points you can write down whatever I'm telling you. Actinoids, uh, generally shows +3 oxidation state, but they can show oxidation state up to +7, right? Lanthanoids also generally shows +3 oxidation state, but they can also show oxidation state up to +4. +7 is not possible in case of lanthanides. Okay. One important difference here it is lanthanoids are generally uh, non-radioactive. Lanthanoids are not radioactive, with one exception here, that is except a element called promethium. Pm is the symbol of that, promethium. Promethium. Yeah, right. That also we can say. Lanthanides are not radioactive, but actinoids are generally radioactive. Radioactive. Okay. Oxidation state I've already told you. This can show +3 or up to +4. Generally shows +3, but can go up to +7. Right? These are the two, major difference we have. Apart from this, you can also say one or two difference between these two, the series of elements we have. That is, for this lanthanides, this is also, experimental. Like its magnetic behavior can easily explain. For lanthanoids, its complexity is less over here comparatively. So its magnetic behavior is explained easily. Magnetic behavior explained easily. But here is still the study is going on. Magnetic behavior is not easily explained over here, right? With in comparison to actinoids, lanthanoids physical and chemical properties we know a bit more, right? Actinoids is still the research and study is going on. So there are a few 2 3 points. First 2 points are more important, which you can write. Okay. Now next question. The name of the member of lanthanoid series which is well known to exhibit +4 oxidation state. Tell me, which lanthanoid elements shows +4 oxidation state? Cerium. Yeah, it's correct. So for the second one, the answer is cerium. Next question. You have to complete the reaction. And next question is, out of Mn3 plus and Cr3 plus, which is more paramagnetic and why? Can you balance this reaction? Tell me. Mn2 plus. Done. How you balance this equation? See, I'll write down this in the next page. You see, first of all, the question that is given here is MnO4 minus plus how many H plus? We have 8H plus and 5 electron. Okay. So 8H plus and 5 electron. This is the question. We have to complete this reaction. Okay. So you can do this question. It is actually a redox reaction. Okay. So you can solve this question with the concept that you have studied in 11th class redox reaction. Okay. Now, what is the meaning of this thing? H plus here. First of all, this ion comes from what? Comes from KMNO4. This means H plus means the medium is acidic. And since it is a half reactions, so there are electrons also into this. Okay. So now you see in acidic medium, in KMNO4, which is nothing but we'll write here MnO4 minus, and this converts into Mn plus 2. This information we should have. In acidic medium, the conversion is this. Okay, here the manganese is in plus 7 oxidation state, and this is from plus 7 to plus 2. If you see this, this change is there in acidic medium, right? It will go to Mn plus 4 in neutral medium, and then it will go to Mn plus 6 in alkaline medium. This is the change you have to memorize: 2, 4 and 6, right? Now the question is this: MnO4 minus to Mn plus 2. That will focus on that only here. So you see, the question is what Mn. Why I'm explaining this to you in so detail? Because if you remember, this is the second question we have seen in board exam. Last class also we have seen one question based on this balanced question. Okay, Mn plus 2. So this is the change we have. Now the point is the first rule. If you see, what is the first rule to balance a redox reaction? Half reactions in acidic medium. What is the first rule? Can you tell me? Just you tell me the first rule. How do we balance this? Okay. So first we'll check what. First of all, you see this reaction means MnO4 minus or KMnO4 is reacting in acidic medium. That is it. Okay. And we know in acidic medium MnO4 minus goes to Mn plus 2. So I have written this. Now we have to balance all atom first other than oxygen and hydrogen. Okay. We'll balance oxygen and hydrogen on the basis of what medium we have. Correct. So since other than oxygen, hydrogen we don't have here, we have only manganese here. Right? So manganese is already balanced. We don't do anything into it. Now in acidic medium, we know the medium is acidic. In acidic medium, we'll balance oxygen by adding water molecule on the other side. Here we have oxygen, so we'll add water molecule on the opposite side. But how many water molecule? That depends on how many oxygen atom we have here. So we have 4 oxygen atom. So one H2O molecule has 1 oxygen. So we'll multiply with 4 here. So we'll add 4 H2O molecule on the other side. So if you add this H2O, you see the oxygen is balanced both sides, right? Now to balance hydrogen, we'll add H plus on the other side again. But how many H plus? It depends on how many hydrogen we have here. So we have 8 hydrogen, so we'll add 8 H plus. Now if you see this reaction, all the atoms have been balanced. Manganese, oxygen, hydrogen, all the atoms have been balanced. Now we'll balance the charge. To balance charge, what we'll do, we'll just calculate the charge on both sides of the half reaction. Like you see here, the total charge here is, it is what? 8 positive, 1 negative. So we have 7 positive charge here. Plus 7. What is the total charge here? Plus 2 and 0. So we have 2 positive charge. From 7 to 2 you have to go. It means you have to decrease this charge by 5. So for that we'll add 5 electrons on the left hand side. You see 7 minus 5 gives you 2. So here the charge is also balanced. Atoms we have already balanced. Right? So that's why you see the left hand side of the reaction is given in the question. MnO4 minus 8H plus and 5 electron. So when you do this, you will get Mn plus 2 and 4H2O, which you have already given the answer. So your answer is correct. Understood? Okay. Last question you solve. Out of Mn3 plus and Cr3 plus, which one is more paramagnetic and why? Tell me. Correct, Vishist. Mn3 plus is more paramagnetic since it has 4 unpaired electron. You can draw the configuration, you will get the same. Got it, all of you? Guys, all of you done? Mn3 plus? Yes, more paramagnetic with 4 unpaired electron. Okay. Next question. Complete the following reaction. Again, you see this reaction is again the same thing that I have discussed now. Can you do this now? How did you get this? Again, you see, see, first of all, this Cr2O7, again, there are two possibilities. It can go to 2Cr3 plus when the medium is acidic, or it can convert it into CrO4 2 minus if the medium is basic, right? So again, this thing you have to know, right? CrO4 2 minus in basic medium and 2Cr3 plus in acidic medium. Now you see the reaction is what? Cr2O7 2 minus, since the medium is basic here, basic medium, so this will convert into CrO4 2 minus. This you have to memorize. There are few things here you have to memorize. Like in the previous example, I've given you for KMnO4, that is MnO4 minus. This is now for Cr2O7 2 minus. Acidic medium Cr3 plus, basic medium CrO4 2 minus. Now you see, again you have to balance this, right? So medium is basic. So what I am doing here, you just try to look at this example very carefully. You must have done the balancing of reaction, and there are two set of rules, one each for acidic and basic medium. Yes or no? Yes, you must have seen one set of rule for basic medium and one set of rule for acidic medium, correct? For balancing of redox reaction. Yes. So what I'm asking you to do here, you just forget those rules which you have studied for basic medium. Okay, just you let it be those rules. Basic medium rule, you let it be. Only you memorize the rule of acidic medium. We are going to use the same rule here, and you take care of one thing here, the medium is basic, but we are going to apply the rule for acidic medium. And once we balance all this, just one change will do in the last, and the whole question will convert into basic medium. So the benefit of this thing is what? You don't have to memorize the rules for basic medium separately. Okay, so let me do this first, you will understand. So first of all, you see, we'll balance all the atoms other than oxygen and hydrogen. So again, you see here we have 2 chromium, so we'll add 2 here, right? Chromium is balanced. Now we have 7 oxygen here, 8 oxygen here, 8 oxygen here. So to balance oxygen, we'll add H2O molecule. Only one H2O molecule will add. So that 7 plus 1, 8 oxygen, 8 oxygen this side. Now we have 2 hydrogen. To balance this hydrogen here, we'll add H plus on the other side. And how many H plus? Since 2 hydrogen we have here, so we'll add 2 H plus. Now all these things we do in acidic medium also, right? Next thing is what? We have to balance charge. What is the total charge? 2 negative here. What is the total charge? 2 positive and 4 negative. Yes. So we have 2 into 2, 4 negative and 2 positive. So we are getting 2 negative, is it? Okay. So the charge is balanced here. So we don't have to do anything into it. Now the point is, all these things we have done according to acidic medium, right? According to acidic medium. But since the question is in basic medium, so what we'll do here, what change we'll do in the last, This you take care of. That what change will do here, that the number of H plus you are getting here, equal number of OH minus ion, you have to add both side in the reaction. You will convert the whole reaction into basic medium. So what we are doing here, till here we have followed the rule of acidic medium. Now to convert this into basic, since we have 2H plus, we'll add 2OH minus here, right? Since we have 2H plus, we'll add 2OH minus. If you have 8H plus, we'll add 8OH minus. 2OH minus, we have added this side. So to balance this reaction, to maintain the the number of atoms constant both side, 2OH minus will add on the left hand side also. Right? Now what happens, we'll write down the net reaction now. This 2H plus and 2OH minus gives you 2H2O, right? And this 2H2O, and left hand side we have one H2O. This will get cancelled and we are left with one H2O molecule on the right hand side. So the whole reaction becomes it what? If you have done everything correct, you'll get the left hand reaction, left hand molecule here exactly it is. You see the molecule is Cr2O72 minus plus 2OH minus, and it gives 2Cr042 minus plus H2O. This is what the answer you were getting, right? You see, this is the question we have. Cr2072 minus plus 2OH minus. The answer will be 2Cr042 minus plus H2O. So nothing you have to memorize here. Did you understand this? That's why we do not have any free electron here, Vishish, you see. Since the oxidation number is same, there is no free electron present here. You see, there is no electron present. Right? So what is the, see, you only have to memorize the rule for acidic medium. To convert this into basic medium, the number of H plus you are getting, equal number of OH minus, you have to add both side, and then you have to write down the net reaction. All of you understood this? Okay. Now the second question is what? Again, you see the KMnO4 minus acidic medium converts into what? Converts into Mn plus 2. So here the product will be what? MnO2 plus 4H plus we have, so 2H2 will get here. 2H2O. 2 plus 2, 4. Yes, correct. Got it? Okay, what is this answer? Zn is not considered as a transition element. What is a transition element? Can you tell me the definition of transition element? Difference between the transition element and D block elements. Transition element are those elements which has partially filled d orbitals. When d orbitals are completely filled, it is d block elements, right? Partially filled d orbital. If you draw the electronic configuration of Zn, you will get the completely filled d orbital. It is not partially filled. That's why it is not a transition element. It is a d block elements. Why transition elements forms a large number of complexes? Why transition elements forms a large number of complexes? Answer. Yeah, right. High nuclear charge and availability of d orbitals. Correct. That's why it forms complexes. Third one, the E naught value of Mn3 plus to Mn plus 2 couple is much more positive than Cr3 plus to Cr2 plus couple. The reason behind this is what? The third question. Okay, you draw the electronic configuration of Mn3 plus and 2 plus and see which one is more stable. Okay, draw the electronic. Yeah, that's what. When you draw the electronic configuration, you will understand. Mn2 plus is highly stable because of half filled electronic configuration. Okay, that's why its E naught value is much more positive. Got it? Okay, next question we'll see. Give reasons. Right. Since nitrogen does not have d orbital, it cannot show pentavalency. So the second molecule does not exist. Phosphorus has d orbital, it can expand its octet. Correct. Yeah, right. Second one, you tell me. 27 2. Electron gain enthalpy is low because small size. Yeah, small size, it has high electron density, so it can produce more repulsion to the coming electron. That's why its electron gain enthalpy is less with negative sign. Yeah, right. Third one, S3PO2 is stronger acid, stronger reducing agent than H3PO3. Yeah, right. In S3PO2, the oxidation state of phosphorus is +1, and that of phosphorus in S3PO3 is +3. So in S3PO2, it has more tendency to increase its oxidation state, right? And can easily get oxidized and act as a reducing agent. So reduction tendency or the reducing behavior of S3PO2, since it has lower oxidation state, is more to that of S3PO3. Okay, next question. What are emulsion? What are their different types? Give one example of each. Emulsions are liquid colloidal solution. So we have actually, there are two types of emulsion. Okay, just write it down. There are two types of emulsion: water in oil and oil in water. You see, first one we have oil in water, that we also write like this, O/W, oil in water. Okay, example of this is milk. Milk. And in this milk, the dispersion medium is water. dispersion medium is water and dispersed phase is oil. So this is oil in water emulsion. Example is milk. Water in oil. Water in oil given in NCRT. Will write as this. Example is butter. Butter. And in butter, the dispersion medium is oil. It's reverse actually. Dispersion medium is oil and dispersed phase is water. These are the two types of emulsion we have in general. With example, you must remember. Always try to write down, support your theory with some example. So always good. Understood? Next question you see. Let me check this question. The following data were obtained during the first order thermal decomposition at constant volume associated to this and this. Okay. The following data were obtained during the first order thermal decomposition of SO2Cl2 at a constant volume. Reaction is also given. Two experiments and data are given here, time and pressure. You have to find out, it's not written here, you have to find out the rate constant of this reaction. Rate constant, which is K, is equals to what for this reaction? Solve this. Done. 1.38 into 10 to the power minus 2. Okay. Yeah, it's right. All of you have done. Purvik, you got the answer? Okay. So no need to solve this, right? Just write down the expression for first order of K, which is 2.303 divided by T log of initial pressure P naught by P naught minus P. Okay. So the time is given. K you have to find out. What is P naught? If I see this equation, I'll just write down here. Initially it is P naught 0 0, and then it becomes P naught minus P, P and P. So total pressure will be what? I'll just write down this very quickly. Total pressure will be P naught minus P plus P plus P. So P naught plus P. This is equals to what? At 100 seconds, 0.7. P naught is 0.4. So P is 0.3. P naught is zero point 0.4. P is 0.3. You substitute here, you'll get K value as 1.38 10 to the power minus 2. What is the unit of K? What is the unit of K? Tell me. Second inverse, right? So don't forget to write down the unit also. Always. Second inverse. First order reaction, second inverse is the unit. Sorry. Yeah. Next question you see, question number 24. Oh, this is the abstract question, I think. Okay. This one. Yes. Account for the following. Primary amine have higher boiling point than tertiary amine. Reason for this? Hydrogen bonding in primary amines. Yeah, so the number of hydrogen bonding, even in tertiary amine, hydrogen bonding is not possible. In primary amines, possible. So due to intermolecular hydrogen bonding, primary amines has higher boiling point. Correct. Second one, aniline does not undergo Friedel-Crafts reaction. Why? Yeah, see what happens. The basic nature of aniline reacts with the acid which is used in Friedel-Crafts reaction. Okay, that's why it does not go under Friedel-Crafts reaction. It reacts with acid and forms a salt. Right? AlCl3 is what? AlCl3 is a Lewis acid, right? Due to electron deficiency. So it can accept the lone pair of nitrogen atoms. So it reacts with that Lewis acid AlCl3 and forms a salt. That's why it does not go under Friedel-Crafts reaction. Right? So that's the reason. What is the third one? Is more basic than CS3 whole thrice N. What is the conjugate acid of CS3 whole twice NH? Okay, CS3 NH2 plus. So this will get stable. Okay, you see one more thing you can understand here that see the question is in aqueous medium. I'll just give you the detail thing of it. When methyl is there and when ethyl is there, then what happens? Okay, so you see first of all there are two things here. If you remember, I have done this in the class also. I'll just give you the quick you know revision of this so that you can understand. This is an important question as far as any competitive exam or board exam is concerned. See, when gaseous phase is there, in case of gaseous phase, like Purvik, this Vishesh said that because of plus I, it gets stable. So that is possible in gaseous phase only. In gaseous phase, it is only defined by the plus I nature of the alkyl group, plus I nature. Okay, and that is why the order of basicity of 3-degree amines will be maximum, then 2-degree, then 1-degree, and then NH3. This is the order in gaseous phase. But when we have aqueous phase, then there are 2-3 things which comes into the picture. Okay, like suppose if I take the primary amine RNH2 in aqueous phase, which is H2O, it forms RNH3 plus OH minus. right? Now this shows hydrogen bonding, right? And the reaction has tendency to go in forward direction, right? But the number of hydrogen bonding you see here, we have 3 hydrogen, so 3 hydrogen bonding will be there. If it is secondary, then the number of hydrogen bonding will be what? NH2 plus. It is less than the previous one. And with tertiary, I'm not writing down the whole equation. This will be R3 NH plus. Even the number of hydrogen bonding will get reduced, right? So the number of hydrogen bonding will be maximum in case of primary amine, then secondary, and then tertiary. But this is not the only, factor we have here, right? Second thing, what happens because of hydrogen bonding? Because of hydrogen bonding, the stability will be more over here, more solvation, more hydration energy will be there. So because of hydrogen bonding, this one is most stable, then this, and then this. But according to I effect, if you see, three alkyl group, this one is maximum stability, will have maximum stability, then this, and then this. So we have the reverse order. So two factors, one is hydrogen bonding and other one is I effect. Both are contradictory to each other, right? So in this case, when more than one factors are there and those factors are contradictory to each other, in this kind of cases, the result becomes experimental in these kind of cases. Okay, it depends on which factor is dominating when. According to that, the result will be there. Okay, so what happens here? It has been observed that if the R is CS3, if R is the alkyl methyl group, if R is the methyl group CS3, right, then the order of basicity is found to be secondary amine we have maximum, then 1 degree, and then 3 degree. But if R is any other molecule other than methyl, higher molecule like ethyl, propyl, butyl, whatever it is, if methyl is not there, any higher alkyl group is there, then the order is found to be secondary will have maximum, then tertiary, and then 1 degree. Right, so all these things you have to write down in this reasoning. Okay, that in aqueous phase there are two factors, hydrogen bonding and I effect. Both are contradictory to each other. So in this case is the result becomes experimental, and it has been observed that according to kb value, that secondary amine is more basic than primary and then tertiary in case of cs3, and R is any other group other than cs3 like c2h5 or ethyl, propyl, butyl, whatever it is, then the order is found to be this. Because when the alkyl group increases, so we'll have steric hindrance also around it, right? That steric hindrance will also come into the picture. So hydrogen bonding, I effect, steric hindrance, steric crowding around the nitrogen atom. Got it? So the keyword here it is what? Hydrogen bonding you can say, steric hindrance you can say, and the I effect you can say. But in case of gaseous phase, I effect is the dominant factor. So we'll only decide according to the I effect. More alkyl group, more will be the I effect, and hence more will be the basicity. Understood? So this is very important one. Okay, next question we'll see. Hmm. Tell me the answer. The first one is CS3I, second one is CS3Cl. And why is it so? Why CS3I? Reason? Both are primary halide. Okay. In first case, both are primary halide. Why CS3I is the answer? Answer is correct. Your answer is correct. But why CS3I? Yes, primary alkyl halide go under SN2, correct. But first question, if you see, we have CS3Br and CS3I. Both are primary halide only. Guys, what is the answer? Tell me. Yeah, simple. Iodine is the better living group, right? Iodine is the better living group. So in case of CS3Br and CS3I, removal of iodine is easier. That's why it easily goes under SN2 reaction or faster. The reaction rate will be more, right? So the keyword is what? Be iodine being a better living group, it can react faster in SN2 reaction CS3I. Okay. In second case, what happens? What is the reason of CS3Cl to be the answer? Why CS3Cl is the answer in the second one? Because the first one is tertiary halide and second one is primary. So tertiary halide has more tendency to go under SN1 reaction. Okay. Formation of carbocation is easier over there because tertiary carbocation is more stable. Okay. So CS3 whole thrice Cl goes under SN1 reaction, but CS3Cl goes under SN2 reaction. Okay. Next one you see. Question number 20A. The reagent is PCl5. This is pentachloride. It is PCl5, phosphorus pentachloride. Instead of OH, we'll get Cl over there. Correct. What is the name of this compound? The first compound that you are getting, what is the IUPAC name of this compound? What is the IUPAC name of this compound, the first one that you have got? Is it benzyl? So yes, the ring is not benzene ring. You see that? And Visist, you cannot write down, cannot write space in between. Cyclohexyl methyl chloride. The name is correct, but space you don't write. Cyclohexyl methyl chloride. Cyclohexyl methyl should be together and then chloride. Okay. What is the second one? What is the answer? What is the product for the second one? Suppose I'll write down the numbering. Suppose if I do first carbon, second carbon, and third carbon. Obviously, bromine will attach. So, at which carbon the bromine will attach? At which carbon bromine will attach? Markovnikov. Do we have uh, any kind of shifting here so that we can get more stable carbocation? Is it possible? See, first of all, the H plus will attach at first carbon. Okay, and we'll have positive charge on second carbon, right? Okay, then we can have 1,2 hydride shift, right? Hydrogen from the third carbon will attach onto the second carbon, and then we'll have carbocation on the third carbon. That is benzyl carbocation resonance stabilized. And then the Br minus will attach on the third carbon. Finally, the answer will be what? The bromine will attach at the third carbon, and we don't have any double bond present in the molecule. Did you get this? See, here the product will be this CH2Cl. Now the another molecule, the second one, the molecule is this HBr. So what happens, this molecule will take this H plus from here and it forms CH2, CH positive, CH3. And then what happens? 1, 2 hydride shift, which makes the carbocation even more stable. CH positive, CH2, CH3. And then the Br minus will attach onto this carbon atom, and the final product will be this CHBr, CH2, CH3. This is the answer in this question. Did you get this? Understood? Okay. Yes. Now you tell me the IUPAC name of this product, the final product you get. What is the IUPAC name of this? One bromo, one phenyl propane. Correct. Okay. The name will be one bromo, one phenyl propane. Must remember this rule that whenever carbon chain and benzene ring is attached, okay, and if the carbon chain contains any functional group, right, halogen also functional group, then we consider carbon chain as the primary chain, parent chain, and we write down phenyl for benzene ring in the name of that particular compound. Okay, so one bromo, one phenyl propane is the right answer. Next question you see. Tell me. Is it dichloro? Is it dichloro? Visist and Purvik. Right, Sai Premnath. Don't write any space between chromium and then oxidation state. Sai Premnath. Chromium, no space, 3 chloride. Don't write any space. Do not put any space over there. Oxidation state is not 2, Shreyash. Okay. So dichlorido, ite will change into ido. 8 will change into ato. Ite will change into ito. Okay, that you must take care of. Don't no do this kind of mistake. You know the answer, but you won't get marks if you do this kind of mistake. Okay, the whole question will get wrong. Take care of this small thing. Okay, COEN whole thrice 3 plus. What kind of isomerism? Is it optical? Right? What is the denticity of this ligand? Ethene 1,2-diamine. Optical isomerism is correct. It is bidentate ligand. Okay, there are two donor atom bidentate ligand. Coordination number of cobalt is what over here? What is the coordination number? The coordination number is what? Yes, coordination number is 6 because one ligand has two donor site. Ethane 1,2-diamine is what? See, again, I am again repeating this. This thing CH2, CH2, NH2. Right? This is the ligand we have NH2. And the donor atom is what? The donor atom is nitrogen here. This will donate electron to the metal. Right? So there are two donor atoms in one ligand, right? So similarly, we have two more donor atoms in the another ligand, right? And two more in the third ligand. You see, so denticity is what? You can do like this, you can write denticity is what? 1, 2, 3, 4, 5, 6. Okay, so sorry, the coordination number is 6 here. Denticity is what? Denticity of ligand is 2 because you have two donor atoms. Okay, so coordination number is equals to what we can write? Number of ligand into the denticity of the ligand. Roughly, we can say this coordination number, right? Second thing, also see, they can ask you this question. They'll give you one formula like this. They'll give you one compound, and they can ask you 2-3 questions onto that. Suppose they can ask you write down the structure of that. Okay, you have to make the structure like this. Okay, then what is the denticity of the ligand? You have to write down the denticity. What is the coordination number? That also they can ask. What are the donor atoms in each ligand? They can also ask you this. So donor atoms here it will be what? Nitrogen and nitrogen are the donor atoms. Okay. So like this, they can ask you hybridization, geometry, anything. So with one molecule, one complex compound, they can ask you 2, 3, 4 questions. This kind of questions you can get in 3 marks. Okay, 3 questions they can frame, 1 marks each. So take care of this thing also. Oxidation number they can ask you. Okay, understood? Do this one. Okay, what is the product we get in Reimer-Tiemann reaction? That is Williamson synthesis. Okay, so Williamson synthesis will get ether. Right, reaction is correct, Vishish. What we get in Reimer-Tiemann reaction? What is the product we get? Can you tell me? Yes. So the reaction, if you write down here, I'll write down the reaction. There are two products actually possible here. Both reactions I'll write down. Okay. So you see the Reimer-Tiemann reaction, we have done this in phenol chapter, alcohol phenol ether. So when you have phenol, OH, and this is allowed to react with chloroform, CHCl3, in presence of a base which is KOH. The product we get here is this mechanism. We have done this in the class, but here you don't require mechanism. You don't have to write down the mechanism here. This compound we call it as salicylaldehyde, right? Salicylaldehyde. Okay. Now, the second reaction again in rimertimine, which we can write with again phenol, but we can also use here carbon tetrachloride instead of chloroform plus KOH. This gives the product as salicylic acid OH and then COOH here. This compound is salicylic acid. So both reaction is possible in Reimer-Tiemann reaction. This reaction we call it as Reimer-Tiemann formulation. And this one is Reimer-Tiemann carboxylation. Okay, Reimer-Tiemann carboxylation, Reimer-Tiemann formulation. Okay, remember with carbon tetrachloride you'll get acid, with chloroform you'll get aldehyde. Understood? So this reaction you have to write down over there. Okay. Next reaction you see. Tell me. Slope is nothing but rate constant. Yes. Okay. Order the reaction is 0, 0. And slope, actually you can easily do this. Suppose the concentration of a dCA by dt minus of dCA by dt is equals to K, concentration of A, that is Ca, right? If it is 1, then we'll get a log term here, right? Since it's a straight line here, and if it is 0, you can cross check like this. So it will be what? You'll get y is equals to mx plus c form. So it will be a straight line. So 0 order reaction it is. Now for 0 order reaction, the slope of the line will be what? Concentration and time. Concentration slope is nothing but minus of k. So it is nothing but the rate constant of the reaction. Got it? When you write down, see the rate expression, whenever you write down, it will always be deconcentration of the concentration by dt minus dc by dt is nothing but the rate is equals to rate constant k, concentration of the reactant species to the power the order of the reaction. Now, whenever you get this kind of question, you write down this expression and then you analyze. If it is 0, then what could be the graph? If it is 1, then what could be the graph? And generally in this kind of question, you'll get either 0 order or first order. Second order you may get, but less. The chances are less for second order. If it is second order also, you can easily find out that if you have 1 by concentration term, then you can get a straight line graph over there. But point is, whenever you write down this relation, after this 0, 1 and 2, you can easily cross check it. Okay, next question. Explain the mechanism. Done. Finished? How many steps are there? Protonation, formation of carbocation, nucleophilic attack. Okay, so 3 steps are there. So, and in this kind of, since they have asked the mechanism, so you have to write down step by step properly. Okay. Step 1. And what happens in step 1? We have primary alcohol CH3, CH2, OH, or it would be better if you show the lone pair of electron here. Just a second, I'll just write down this. Step 1, step 2, and then we have step 3. We have a lone pair of electron here on the oxygen atom, 2 lone pair. This lone pair will attack onto this H plus, and this is nothing but the protonation. CH3, CH2, O, H2, positive charge on it. Okay, protonation of this. Now next step, what happens? This CH3, CH2, OH2 plus, to stabilize this carbocation positive, sorry, this positive charge on this oxygen atom, it will take this bond pair of electron, and we get a carbocation here, which is CH3, CH2, positive charge on it, and H2O molecule will go out. Okay. Last step is what? This CH3, CH2, positive charge on it, and then the nucleophile, which is Br minus here, this nucleophile will attack onto this positive charge carbocation. There is no rearrangement possible here, and the product we get here is CH3, CH2, Br. So this is the 3-step mechanism. One thing you must take care of, the direction of arrow is also important. Lone pair will attack, negative charge will attack. Always negative charge attacks onto the positive charge. Okay, positive charge will not attack. Okay, so that arrow, the direction of arrow is also important in this mechanism part. Understood? The first step is protonation. Second step is formation of carbocation. If there is any possibility of rearrangement, we'll do that also here. And then we'll get the attack of nucleophile in the last step. Understood? What is the slowest step we have here? Rate determining step. What is the slowest step? Step 2. Yes, the formation of carbocation is the slowest step here. Once this carbocation forms, the nucleophile will all of a sudden it will attack onto the carbocation. Okay, so this is the slowest step, or we can say RDS, rate determining step. Next question. Define these terms. What is molar conductivity and secondary batteries? Just a second, you try this. Okay, done. What is molar conductivity? Yeah, secondary batteries can be recharged. Yeah. What is molar conductivity? Is the conductivity power of all ions furnished by 1 mole of an electrolyte present in a fixed volume of solution. Yeah, it's correct. Both definition is correct. Then you after this you write down the formula for molar conductivity also. Okay. And secondary batteries are those batteries. What is the example of secondary batteries? Any example? Can you tell me? Secondary batteries, any example? Any definition if they ask you in the exam. Okay, write down the definition and then you write down one example. Okay, like secondary batteries are the lead storage battery. Okay, which can be recharged again and again. Example, a lead storage battery. Next, this one. Write the type of magnetism observed when the magnetic moments are aligned in parallel and anti-parallel direction in unequal number. It is unequal number, you see. Unequal number is antiferromagnetic. In unequal number, it is antiferromagnetic. Schottky is correct, but it is unequal number, so it is antiferromagnetic. Due to Schottky, density decreases. What happens in Frankel defect as far as density is concerned? Frankel defect does not affect the density. Yes, antiferromagnetic will have equal number of equal magnetic moments are aligned in parallel and anti-parallel direction. Second one is Schottky. Yes. Next one you see. Numerical. See, this type of question, if you observe, we have seen in every question paper every year, one density related question. What is the answer? Just to use the formula of density, that is it. Take care of unit always. Like I said, always in this kind of question, they must change. Sometimes they change the unit also. So you must take care of unit over there. 26.9. Yeah, it's correct. 26.97. It's better to write exact value 26.97. Don't write it 27. It won't be wrong, but it's better to write always 26.97 like you get. Yes, unit is also. Gram per liter, Vishist, or is it mole? Next question you see. All of you have done right. Do I need to solve this? Do I need to solve this? Correct. Okay. So just formula you have to use. Next question you see. Write the name of monomers. What monomers we use for Teflon? Tell me. Tetrafluoroethene it is. Fluoroethene it is, or tetrafluoroethene. Yeah, it's correct. So for Teflon, it is, I write on the formula CF2 double bond CF2. Tetrafluoroethene, tetrafluoroethylene. For buniene, what will write? 1,3-butadiene, which is nothing but CH2 double bond CH, single bond CH, double bond CH2. 1,3-butadiene and acrylonitrile. Right? Acrylonitrile is this CH2 double bond CH and then CN here. So this is acrylonitrile and this is 1,3-butadiene. This is tetrafluoroethene. Ethene, ethylene. Okay. Next one you see, structure. Done. Okay. So how do we, what we calculate to find out the structure of this? First of all, you tell me. What we'll find out, this one is easier. Like you know this S double bond O, double bond O, OH and OH. This is the structure of H2SO4, dibasic acid. What we'll find, calculate to find out the structure of this? Number of valence electron, right? So how many valence electron we have here? 8 plus 18, that is 26. So now the central atom is Xe, and we have 3 oxygen O, O, O. And we'll put what? One bond pair of electron here. I'll just draw it simply. 4, 4, 4. We have 2 lone pair here, 2 lone pair here, and 2 lone pair here. So we'll have 24 total, and 1 lone pair we'll have here in this orbital. The structure of this will be what? Double bond O, double bond O, and double bond O with 1 lone pair here. Understood? Understood. Okay, so we'll see one last question for today. Oh, we have done this. Write down these reactions. Which one is trigonal bipyramid? Both are are sp3 hybridized, right? Geometry is tetrahedral. Yeah. Shape is trigonal. Yeah. It's not see, the shape is trigonal pyramidal. Geometry is tetrahedral. It's not bipyramidal. Okay, XeO3. Okay, so what is the product in the first reaction? Carbon with concentrated H2SO4 that gives CO2 and SO2 H2O. Right now, the balance reaction here. So it will be 2SO2, 2H2O. XeF2 will have 2H2SO4 here. XeF2 plus H2O, it gives xenon Xe, that is 2Xe plus O2 plus HF. We have 2 here and 2H2. This is the product we get in this reaction. Okay, so we'll wind up the class here only. Right, we have solved today like many questions, some small questions and numericals we haven't done today because it was not there in the last part. Okay. Anyways, so you keep on revising these things, and like I said, the small things that you are making mistake. Try to uh, try not to repeat the same mistake in the exam, like the unit. Whenever you write calculation mistake, okay, if you have got it wrong in first attempt, you don't know over there that it is right or wrong. Okay, so while you are doing some calculation, take care of that also. Okay, small things you take care of, you will get good marks. Okay, it's not like you do not know, you know like almost everything, but don't make those silly mistakes in the exam. That's the only key thing you should keep in mind. Anyway, so see you soon. Okay, we'll have wind up the class only. Thank you all for joining. All the best.